Problem number 17. For a bill totaling $5.65, a cashier received 25 coins consisting of nickels and quarters. How many of each type of coin did the cashier receive? Okay, so let's assign some variables. Let's let Q be equal to the total number of quarters. And let's let N be equal to the total number of nickels. Alright, so what do we know? We know that we got a total of 25 coins. So that means that the number of quarters plus the number of nickels has got to be equal to 25. What else do we know? We also know that if we were to look at the total of all these quarters and nickels, that it would total up to $5.65. So that means that 0.25 times the number of quarters plus 0.05 times the total number of nickels has got to equal $5.65. Now, here's the problem. We have two equations, and we have two variables, and we can't determine what Q and N are just by looking at these two equations as they're written. What we would like to have is we would like to have one equation with just one type of variable. Well, up here, you can solve this equation for either Q or N. In fact, if we were to subtract N on both sides, we could declare that the number of quarters is equal to 25 minus N. So, if you know the number of nickels, you take that quantity and subtract it from 25, that will tell you the number of quarters. And what we're going to do is we are going to take this expression for Q and we're going to plug it in for the Q in this equation. And look what happens when you do that. You now have 0.25 times 25 minus N plus 0.05 times N is equal to 5.65. And now we have one equation with one type of variable. The only variable that we have is the variable N. And we can solve this equation for N. Let's begin by distributing. 0.25 times 25 is going to be a 6.25 minus 0.25n plus 0.05n is equal to 5.65. We can combine our n terms together. That's 6.25. 0.25 plus 0.05 is going to be a negative 0.20n is equal to 5.65. Let's subtract the 6.25 on both sides. We have negative 0.2n is equal to, let's see, that's going to be a difference of a negative 0.6. Then we'll divide both sides by a negative 0.2. And that will give us that n is equal to 3. So n being equal to 3 means that we have 3 nickels. So going back up to our original statement that we said that Q plus N is equal to 25, and we rewrote that as Q is equal to 25 minus N. To find the number of quarters, we would do 25 minus N, or Q is equal to 25 minus 3, which means that Q is equal to 22. Let's do a quick check to make sure this all works out. And to do our check, we're going to go all the way back to this equation. Here's my check. 0.25 times 22 plus 0.05 times 3. Does this equal $5.65? Okay, 0.25 times 22. That's going to be $5.50. 5 cents times 3 is going to be 15 cents. And that totals $5.65. Checks out. So we'll come over here and write a nice little statement. How many of each type of coin did the cashier receive? She received 22 quarters and 3 nickels. Okay, final problem. Relationship between distance, rate, and time. The relationship is the following. Distance is equal to rate times time. The distance that you travel is equal to the rate at which you are going times the time that you are going that rate. We have the problem, number 18. It is 530 miles from Lubbock to Denver. If your average speed is 60 miles per hour, how long will it take you to drive from Lubbock to Denver? So, what do we have? We have 530 miles. That's going to be our distance. 60 miles per hour, that is our rate. How long will it take you? How long will it take you? That is our time. That is the quantity that is in question. So if we go to our formula, distance is equal to rate times time. And we plug in our values. We can replace D with 530. We can replace rate with 60, but we don't know T. So, looking at this equation, we need to solve for T. How do we solve for T? We divide both sides by 60. And that is going to tell us that T is equal to 530 divided by 60. Or 53 over 6. We need to divide 53 by 6. This does not divide evenly, but 6 does go into 53 8 times. 6 times 8 is 48. And that's going to give us a remainder of 5. So we could say that T is equal to 8 and 5/6. This is in hours because our rate is miles per hour. This would be an acceptable answer, but I wonder if we could rewrite 5/6 as minutes. So let's do a little bit of work over here. 1 hour is equal to 60 minutes. So 5/6 of 1 hour is going to be equal to 5/6 of 60 minutes. Okay, well, if we put that over 1, then 60 divided by 6 is going to be 10. And then the 5 times 10 is going to be 50. So that's equal to 50 minutes. 5/6 of an hour is equal to 50 minutes. So T equal to 8 and 5/6 hours is the same as T is equal to 8 hours and 50 minutes. So, how long will it take you to drive from Lubbock to Denver? 8 hours and 50 minutes. And that will conclude our notes for applications of linear equations.